This is the fourth and final video on how to use the Kraken template for Vex Robotics. This is final one, at least for now. We'll see. Add more maybe for more complicated things if that's what people need, or for new features. We'll see, but this is the last one for now. So this one is going over your auton.cpp file. This is where you create all your autons. So we recommend having multiple autons. It's very useful. Like in the 2024-2025 game, High Stakes, each different corner was slightly different. So you couldn't just run the same auton no matter where you were. So if you just want to grab this goal and first grab these rings and then grab that goal, you drive forward, turn left. But over here, you drive forward and turn right to go that way. And then these two are different from this side, so you needed a unique auton. Even if it was similar, they were all slightly different, mostly in their turning directions. So you should at least have probably 2 to 4 plus a skills auton. So this is where you create them. Each auton you will create is a function, so I will just go over here and run. So you want to do void, and then you give it a name. Doesn't really matter. So we can just call this one your skills auton. And then you don't need this SCC out, but here's a good example of what you do. So for driving, you're going to need to set your PID constants. So chassis dot drive PID constants, and there are 4 values. The first is KP, KI, KD, and then your drive range. So the first 3 are going to be decimals. Especially your first one will probably be the biggest, with the following 2 being smallest. So it'll be something like 0.4, 0.0002, 0.00003, something like that. You'll have to do testing with this to tune those values to get them right. And then your drive range is going to be something like 10. And this is once the robot has calculated an error and it's close, that is less than this value, it'll stop. So error is the distance from where your robot is to where you want to go. And so sometimes it can get to it has an error of 2, but then that math outputs a very low voltage for the motors, and so it's not actually moving error, so it'll just be stuck there at 2, so it's not perfect. So with this, if it's less than 10, it'll stop that and move on to the next command, which is useful so you don't just get stuck trying to get it super perfect, because it can't always handle that. And end it with a semicolon, and then to move it, it's chassis.move, and then you input 3 values. So the first one is a distance. It's let's go 10 inches. It's not inches exactly. You do have to play with this number, but you can use reference from other things to guess. So we'll say 10. That's for my testing, a foot and a half maybe, give or take. And then the next one is an angle. So in this case, we don't want to turn, so we're going to say 0. And then turn multiplier, just always set it to 1. And then for turning, you do the same thing, but you do turn PID constants and set probably new constants, but we'll just do something similar like that. 10's generally a good one. And you do chassis.move again, but this time you're going to set your distance to 0 and your angle to 90, and then turn multiplier to again 1 and a semicolon. So this will have it drive forward and then turn 90 degrees. If you want it to drive backwards, you just make the distance negative. If you want it to turn the other way, you can just make the angle negative. So this is the best and most accurate way to move your robot during auton. If you want something a little more simple, like if you don't have an IMU or you don't want to use a PID, you don't have to. You can just do chassis.move and just pass in a voltage, which is negative 180, which is backward, which moves the motors in reverse, or moves the robot backwards, and then to 127, which is forward. So if you want to go full speed forward, you just do 127. But you got to make sure you brake so you don't cross the autonomous line or ram into a wall at full speed. So then you can just do pros 2 semicolons delay, and then you pass in the milliseconds. So we'll say, let's go half a second, and then you stop, which you do chassis dot brake, and that'll just stop it after half a second. This way can be a little finicky due to acceleration and timing, so it's not always perfect in getting you to the exact location. But if you just need to be somewhere roughly, this is a good way to do it. And then you can also, like in last video, you can access sensors like rotation.get rotation, the name of it, get angle. Yeah, so this just gets you a number. It doesn't really do anything, but you can do it in an if statement if you want. So if it's greater than 10, do something. You can do whatever you want, just if you want something a little more variable, but that's not something we've ever used. And then also for your other motors, it's going to be similar as driver control. You can do motor.get motor, pass in the name, in this case motor, and then just like up here with the chassis, you're going to do move, and then pass it a voltage. So we'll say like 50, which is almost 30%, a little more, I think. And then you again want to do a delay in milliseconds, so move it for half a second, and then you're going to take this part, dot brake, and then it's similar for your solenoids, but it's slightly different. So ADI digital out dot get ADI, put in the name solenoid. Make sure you're spelling your names right across the entire time, otherwise you will get some errors. Things will not be working. Dot set not config value, and you can either do true or false. So true will generally extend it and false will retract it, depending on how you have it currently set up, like that. And then yeah, so that's all for creating your auton, and now you actually need to set it up so it's usable. So down here in your initialize auton, you're going to add it, like you can see here, and they will be, when you cycle through them, they will go in this order. So first it'll start with test 1, and then when you press the button, it'll go test 2, and then test 3. So if you want your new auton, like in this case skills, to be your first one, you'll add it at the top. Autons.add auton. You're going to give it a name. This is what will display on the screen. So like over here in the config file, it is what will display right here on line 2. So in this case, we'll go skills auton. You're then going to give a description. What I like to do is either give a little bit of info about where the robot is supposed to start for this auton, or how many points, or something like that. So we can say like scores 2 rings in reference to high stakes. It's the most recent game at the time. Scores 2 rings. Start by touching wall. Something like that. You want to keep it short because it has to fit on that one line. It will display right below the name. Short and simple, but something like that. And then you're just going to pass it reference to your function. So skills in this case. And normally when you call a function, you put in the parentheses like we do up here with all these. But in this case, we do not want to do that. It will cause errors and just call it once. So we're just going to pass it reference to it and then end with the semicolon. And I believe that is it for creating autons. You can create as many as you want. You could create 1. You could create 500 if you really need to. And then make sure you save and upload. And that is it on how to use Kraken template. For now, if you have any questions, email us at krakentemplate@gmail.com or leave a comment on one of these videos. And same with bugs or errors you're having. We'll try and help you or fix it as fast as we can. All right. Thanks for watching these tutorials.